Chapter 7, page 5. The last thing we're really going to cover in this chapter are the synthesis of double bonds. And really, this material is left over from Chapter 6. We already covered it in Chapter 6, but since we use it so much to build molecules and do synthesis problems, we're going to go ahead and review it one more time. So, if I have an alkane molecule here, and it has an alcohol on it, then I can dehydrate that alcohol with strong acid like H2SO4. Now, adding a base to that alcohol doesn't do a whole lot if it's regular hydroxide, but adding H2SO4 does. And what it will do is, and we saw this in the chapter, is you'll end up doing an E1 dehydration. So, if you have an alcohol and you do an E1 dehydration, you're going to protonate the alcohol, one of the lone pairs on here. A water molecule will leave, you'll get a carbocation, it might rearrange, but in the case that we have in this molecule, I'm just plain old going to get an elimination reactions to the more substituted position, and this will be the major product. E1 dehydration of an alcohol, carbocation, possible rearrangement. In this case, we won't get it, and then you eliminate to the more substituted double bond if you can get it. Now, the other way to make double bonds is by taking an alkyl halide and doing an E2 elimination, adding a strong base to it. If I add a small base like hydroxide or methoxide or ethoxide, which is what I've got drawn right here, and heat it up, I make sure that I get the E2 elimination product over the substitution. And as long as I can get an anti-hydrogen, I'll get the more stable double bond, and trans is favored over cis. If I have a bulky base like T-butoxide, then it can't reach the inside hydrogens on this carbon right here. And so I'm going to go for the outside hydrogens on the other carbon, and I'll get the less substituted double bond. We covered these reactions in Chapter 6, but since we're going to use them an awful lot for synthesis, it's not a bad idea to go over them. Remember, adding acid to an alkyl halide won't get you anything. It'll just sit there and look at you. And adding a base to an alcohol doesn't do anything in this case. Just adding like hydroxide to it doesn't do anything. You have to add acid to the alcohol and base to the alkyl halide, small or bulky bases, in order to get these elimination reactions to work. Now, another section in here is going to be the catalytic cracking, but I'm not going to ask you that. So you're not responsible for two industrial methods for prepping these things. Oh, I do want to say one thing about the bulky bases. This chapter does cover a couple of other bulky bases. One of the common ones is if you take a nitrogen and add 3 methyls or 3 ethyls, usually 3 ethyls. This thing becomes pretty bulky, and it will work like T-butoxide. So another bulky base to be able to do these E2 eliminations to the less hindered side to make a less substituted double bond like this. The chapter gives 1 or 2 other ones, but triethylamine is one of the more common ones. We might not use it as much as T-butoxide because, well, triethylamine stinks. Nitrogens kind of tend to stink. But the T-butoxide is a common one, but you might see triethylamine.